Good morning, everybody from Accra, Ghana. Good afternoon to you in Kenya, Habari, Awatoto, Bonjour in all the Francophone countries. You are all welcome to the 7th in the GAIAthon webinar series. And today, our topic is on bridging knowledge and innovation, a journey from campus to IoT entrepreneurship in Africa. To give us this presentation will be Samuel Adranyi, who is a seasoned technology entrepreneur, Microsoft Azure MVP, ambassador, and a leading advocate for IoT and AI innovation in Africa. Samuel has over 15 years of experience in this field, and he bridges academia and practical entrepreneurship. He is also pioneering initiatives that tackle pressing environmental and societal challenges across the continent. He is the founder of Crafted Climate, where he leverages IoT and AI to promote sustainable living solutions and position his work at the forefront of climate innovation. Samuel actively champions youth empowerment, highlighted through initiatives like Tech on Wheels, providing hands-on technology education to underserved communities. Samuel inspires young Africans to translate academic learning into impactful entrepreneurship, driving forward Africa's digital transformation agenda. So for you, the students who are involved in this program, it is pertinent that we learn from Samuel, whose experience will guide us as we develop our solutions. Ladies and gentlemen, I would like to welcome Samuel Adranyi, our speaker for today. Samuel, kindly take over and share your screen. And for our Francophones, please activate the language captions to suit yourselves. Thank you very much. Samuel, you have it. Kindly unmute yourself and take over, please.
Thank you very much, Prof. Just want to be sure, mic check, if you guys can hear me very well. Maybe you can give me a thumbs up or something just to know
we can see you, but we can't see your slides yet.
Okay, yes. So I'm going to get the slides running. Let me get this going and share my screen so that you all can see. Let me know if you can see my slide.
Perfect. You are on now.
Excellent. All right. Thank you very much. Good morning, good afternoon, good evening, wherever you joining us from. It's just about 3 a.m. my time where I am currently, but it's always exciting and interesting to come here and share my knowledge and inspire the next generation of you who are going to move or transitioning from school into entrepreneurship with all the opportunities that there are. So I'm just going to kick right into it. As you know, the host mentioned, we're going to be talking about the knowledge, bridging knowledge and innovation, which is a journey from campus to IoT and entrepreneurship. I'm going to tell a story mostly. My journey, this session is going to be mostly about my story, my journey into where I started and where I am now, lessons learned and how I transition into what it is right now. So with that said, I want to begin my conversation with a little story. What you're seeing right here is where I was born. Unfortunately, today this is how it looks like because the whole place has been torn apart. And if you look closely, you will see areas like a military barracks. You see there's a military workshop. There's a police workshop. There is so this is where I was born. This is where I grew up. I grew up around curiosity. I grew up around sports vehicles. I grew up around carpenters. I grew up around artisans. I grew up around, you think about it, a place where creativity and innovation naturally flourished. And this, I believe, laid the foundations and the basis for my interest in solving problems and applying, technology. I want to begin this session by saying that innovation always begins when curiosity meets purpose. And that's why I'm sharing where I started from. Because there's always a misconception and perception that people who are in technology or people who are seen to be doing well in technology today must have come from some affluent or some influential or some rich family with all the money to buy and throw things at them. But I'm here to tell you that that's not the story. I came from a family where my father was a police officer and my mother was a petty trader, sold firewood, sold charcoal. You think about it, the menial things. But today, I have moved from this, what you're seeing on your screen, into something that is a much bigger. And that is what today I'm going to walk you through the journey of my story and how I transition from that, from what you're seeing, this emptiness, into what it is today. Let's start by first just a little about me. I know a lot of introduction has been done, so I wouldn't want to go much about it. But just like you said, yeah, I have a little over 15 plus years in technology, across board with emphasis on AI, IoT, extended reality, and then cloud solutions architecture. That's areas that I'm focusing on. I'm currently the CTO and founder for Afrologic Solution and also Crafted Climate, where we are trying to find localized, sustainable ways of environmental monitoring and managing, and also to prevent, this whole global warming issue. I'm also the application system manager for Mecoma, which is a US-based company, where I also use my skills and experience to help them digitally transform their businesses. I currently help run three user groups in Ghana, which is the Accra.net and Azure user group, the Accra Power Platform user group, and then the Global AI Accra chapter user group. From time to time, you find me streaming on YouTube Tuesdays on IoT. As you can see, I'm quite passionate about IoT. I do live streams on YouTube, LinkedIn, Facebook, or multi-stream on Tuesdays on IoT. And then on Fridays, I try as much as possible to share general knowledge on technology. But this in recent times, my focus has been AI Copilot and how to leverage it. And then on Sundays, I try to, bring things up a bit, a little, onto the power platform of things. But let's get into it and talk about the journey to today's session, right? And like I mentioned, growing up, in Ghana, I I probably didn't imagine, that one day I would probably be designing hardware devices to help fight air pollution or climate change, or validating carbon credit, carbon sequestration, and stuff like that. This journey actually took a turn in 2010, where I walked into Radio Shack. Well, Radio Shack is or was, let's put it that way, was one of the biggest hobby shop in America, where you could walk in and get all sorts of things and kits, and then play and test things around. That is what it was. So I walked into Radio Shack 2010. Um, Someone introduced me to Arduino. I bought a $30 Arduino kit, and it was on a Friday. And by Sunday, I was hooked. I originally studied mathematical science at the University of Ghana. It was supposed to have been computer science. Well, so I thought. I was excited about going into, the university to learn computer science because I was a little privileged to have started coding in primary four. I was very young, writing QBasic, COBOL, and some of those crazy things at a very, very young age. So by the time I got into the university, I was actually teaching and learning advanced concepts in programming before I went into the University of Ghana. I was excited, I was going to do computer science as they would have it because you need to add a degree to that exciting phase. I went in there only to realize that it was a very mathematic heavy program. To make things even worse and compound that for us, we didn't have the opportunity to have a lot of practical sessions. We had a small lab, which was crunch time. We didn't have enough lab time to even program. Most of the program compilation we learned in school were done on the blackboard. So you can imagine, if not for the fact that I had already started to program and learn on my own, thanks to my parents' dedication before I came to school, that would have been a disaster. I saw many of my friends drop out from that course because, one, it was too mathematical, and two, there wasn't a lot of hands-on experience, and it was just study, chew, pour, pass, and move out. So there wasn't a lot of application. I can't remember my year was when they started a computer engineering department, which we were envious of because at that time we felt that they had it at a more lenient and were going to do more practical computing. Well, we were wrong. A lot of my friends who did that course, mostly till today, are still finding it difficult to actually implement things because at that time, even the basics of microcontrollers like Arduino were not present in the university. Hopefully today that story is different. But this is me after studying computer science, all the mathematics and everything, and writing software for a long time in my life, being exposed to Arduinos. And today, I'm sure if you're on this call, you probably have heard or seen about Arduinos. And that is where my life changed. That is where my life took a turn for the better or for what I am today. So let's take a quick trip to, just to understand this whole thing we're talking about IoT and this whole thing about how, some of us have made a business out of it. But one thing that struck through with me was the fact that it ignited my passion. And also the fact that it was available for me to test out, it was available for me to geek out with. And that is what is the driving or deciding factor for whether you make it into this project or you make it as an entrepreneur or not, and which I would express a lot more. So let's just take a quick trip into, what is IoT per se? Obviously, we're talking about IoT or how to, get this bootcamp or hackathon going? Well, basically, I would define IoT as a network of internet connected physical objects, right? With embedded sensors. We talk about the companion software, and then you can talk about the other technologies, right? That is able to first of all collect, exchange, act on data. Now, it aims to actually extend internet connectivity beyond just traditional devices. So before then, you talk about only probably your phones, your computers, or laptops that had internet connectivity. Today, we're talking about smart glasses, as you find me here. This is a smart glasses. It's smart is generating data. You can talk about smart microwaves, smart fridges, smart devices. And it's actually, determining that the number of smart devices connected per second is even more than human beings. So that is what IoT generally we define that is. But IoT is not just a recent conversation as most of you might think. Actually, IoT dates back into the 80s. Let me take you back a bit further. The first recording or the first instance of an IoT device or IoT setup was actually this prehistoric Coca-Cola machine, dispensing machine you're seeing here. Now, one of the important things you need to note and take in mind is that the curiosity for this was that it was basically just reporting whether Coca-Cola was cold or was not. Someone will say this is quite very trivial for just something to determine whether something was cold or hot was defined as IoT. Yes, this happened in 1982. Now, why am I laying emphasis on the fact that it's just something you would think is mere to say it is hot or cold? That is because a lot of the times it is just the basics or the little things that we need to drive solutions for, not to over engineer or to over complicate things, right? Now, one thing that is also dominant is the fact that this whole concept that we're hearing now of AI, IoT, and all that is part of what we call the fourth industrial revolution. Now, the fourth industrial revolution, as you can see, we emerged from, the coal, the steam, the electricity, the internet, and today we're in the fourth industrial revolution. And in this fourth industrial revolution, we can see that the key technologies that take center stage in the fourth industrial revolution. You can talk about IoT, you can talk about autonomous systems, you can talk about cloud computing, there's big data or data management, and there's also AI, which is part of the big fourth industrial revolution. That means that today, if you're planning to build something that is sustainable for the current generation or revolution we are in, and even moving to work 4.1, you need to have these skills or you need to have this into whatever solution you're providing. Now, so one may ask, we've described what it is, where its role it plays, the technology it plays part of the fourth revolution. What is IoT? Well, Come with me on the journey. Well, as a beginner, when you're learning IoT, you face a lot of challenges, right? Initial challenges. For example, that fateful Friday when I walked into Radio Shack and bought that Arduino kit, right? The smallest Arduino kit. I stayed up all night, right? This is me trying to understand, how this physical computing device would help me implement my knowledge of, computer science or programming. Learning IoT wasn't easy for me, right? Like I mentioned, I had to stay up late. I fried a lot. I fried a lot of the components. Wired components differently. I struggled through a lot of the things, right? Lots of errors. But once again, remember where we started from. There's passion, there's curiosity, and a desire to create something new. Things were the burning desires that kept me going. So even at some point in time, right, where I wasn't getting it. I wasn't getting a lot of documentation because at that time it wasn't popular. I had to reference things, break things, restart all over again. But in all that, I saw the technology was not just as a tool, but also as a language for me to solve problems. And almost immediately, that idea of making sure that the more I understand this concept, the more I understand and use this, it could help me solve a lot of problems back home. And that is what I always had. Being able to learn these technologies, being able to implement them, to get better at it, to be able to solve problems back home. Little did I know that this sleepless night, this firing of components, this C++ errors, and all these problem solving skills for physical computing I was learning way back in 2010 was actually helping me metamorphosize into this little cocoon into a butterfly that today would actually provide solutions. And after a while, probably after just a week or two, this is how my home setup started looking like. I started investing in a lot of boards, as you can see. And for some of you who didn't know, Samsung at some point had their own dev board, which was the Arctic 5. I had the opportunity to use Arctic 10 as well. At the same time, I got opportunity to play around with Zigbee, to do Z-Wave, more Arduinos, to do RF, and also Raspberry Pi as far back as that time. There were a lot of boards that had coming from China, Omega, the Arduino, you can see relays. And the passion and the desire and the lack and the hunger, because I didn't get it from school, was just driving me to acquire and to just understand and build it. I thought I was just learning. I thought I was having fun. I thought it was just a passion. But little did I know that this was preparing me for something bigger. Now, how did I build the skills and how was that approach? Well, this is how it looked like. What I did was that I ensured that I leveraged every opportunity I got. Online communities, free courses, open source platform, but most importantly, every step of the way, I built a very small project that taught me the real applications of it. This is where I got introduced to Hackster. Some of you might know about Hackster, some of you might not know about Hackster. Now, I'm a Hackster ambassador for both here in the US and then also back in Ghana. This then at that time was a niche of community people who were passionate about trying new devices, trying new hardware. So it was quite interesting that what happened was that we go for meetups every Friday or sometimes Saturdays, and you have the likes of Intel. Fortunately, where I am right now is where the Intel headquarters is based. So we got access to Intel boards like Edison. They would just give us the boards to go try it and give them feedback. And that placed me at a position where I got the opportunity to learn a lot. Now, that's the good side of it. Today, there's not a bad side, but there's quite a challenging side of things as well. It is time commitment. Today, with this rapid movement of time, we need to commit to it to make sure that we are actually understanding where we are. Well, it requires significant time investment to engage with the resources and the project. I know sometimes, combating it with school and stuff like that. I always get this question. Somebody asks me, that Sam, how do you do it? You stream on Tuesdays, on Fridays, on Sundays. You work full time. You have a family. How do you combine it? Again, going back to the passion, the curiosity, and the dedication. and also having a family that understands that that is my passion and something that I share through it. Now, this passion I carried through actually, as the years went by, actually led me to win two grand prizes in the Hackster UNDP challenge when COVID came. I won the grand prize for the best COVID detect and protect challenge, which was just a smart water dispensing, soap dispensing, and system, because in COVID time we're avoiding human contact, which were just developed basically using PVC pipes and then some sensors, some motors and stuff like that, because they were built from recyclable materials or cost-effective materials, and they could easily be reproduced. Again, remember the small things, the small things we look at. So all these skills and all these exposure and all these, meeting people, connection, taught me one thing: skill grows with practice, not perfection. And that is what I want all of you to carry. Your skill will grow with practice, not perfection. And that's why I say that for every step you take, you need to make sure you are building small projects to practice. What happened in 2024? This brings us to moving from academics, moving into the community, and now the journey towards entrepreneurship. This was 4th February 2024, and the air quality in Ghana was 371. Now, per the air quality index, this was hazardous, very, very hazardous, and very bad for people across all demographics. Now, we were not getting, adequate reporting. We didn't understand why we didn't see this. We couldn't anticipate this. We couldn't report that. And that led, again, the curiosity in me was like, what is going on? Asking the right questions, understanding what was happening. And that is when we realized that in the whole of Ghana, there was only two active reference air quality monitors at that time. One was at the American Embassy, which obviously is a no-go, so it wasn't our device. The second one was at the physics department of the University of Ghana, which is also centered at just one place, and therefore could not give us enough information on the different places that we could report air quality data from. So, and this is where the idea and the curiosity gave birth to what I'll share with you today, and how we took this from just a thought, try to solve a problem, into a business. Welcome, Crafted Climate. So Crafted Climate started as, like mentioned, was it a simple question? If we only have two reference monitors, why can't we measure our environment ourselves? Why should it be in the US Embassy? Why isn't there not a way for us to, be able to measure our environment, whether it is soil, whether it is air quality, whether it is ambient? How can't we do that locally? And that is how we started. No one was manufacturing affordable, localized sensors in Ghana, or to say, even in West Africa. At the time we were looking into this, nobody had ventured this. It was only in Uganda where a professor was trying to do something with a student, and they got some funding from Google, and they started building something. We're like, wait a minute, we could also do the same thing. So something that started from just simple asking questions and how we could solve that problem, we came up with it. So first of all, the initial question about measuring. There was a lack of sensors. The absence of affordable sensors in Ghana was identified. And we decided to say, you know what? Why don't we build our own sensors? Then that is when the building process began. So as students moving from school into the world of entrepreneurship, this is how your curiosity graph should look like. Ask the relevant questions, identify the problems, take a bold decision to say, I want to solve this problem, and start the journey for it. And I'll walk you through that journey. Now, this process we started in 2024 gave birth to what you're seeing today as Crafted Climate. In the top right was our first iteration of the sensors, which had onboard solar panels on it. Some didn't have, others had. And this and this was the challenge. This is our first time, venturing into it. We did a lot of rudimentary mistakes. We found out a lot of issues. The solar panels were not, providing enough juice to run the devices at night. we found a lot of issues in the very first iterations of them. But thanks to the persistence, thanks to connecting with partners, connecting with friends, connecting with industry partners, the iteration process. We try something, it doesn't work, we go back to the table, we redesign it, we do that. We've come up with almost the final version, which you're seeing on the top right. Today, we have the CrowdSense gas, and then we have the CrowdSense M. Now, below it is the line of sensors that are currently being in development. So you can see the CrowdSense gas, you can see the CrowdSense Terra, and the Terra is for soil moisture, pH, potassium, soil conductivity, and These are all smart sensors that reports alert.
Hello, Sami.
Variants, the CrowdSense M, which is for environmental monitoring, which monitors up to 10 data points, including PM1, 2.5, 10, temperature, humidity, pressure, noise, light, and all that. And this, we have a utility pattern for all this. We also have the CrowdSense gas, which reports LPG, CO, CO2, methane, ozone, you think about it. And all these sensors they are modular, they are configurable. You can change them to either monitor single data points or multi-data points. And these are some of the benefits we looked at in trying to drive it to meet commercialize it and be able to move into enterprise with it. We looked at, a couple of things that we realized the value proposition. First of all, they have localized AI on the edge, which means they're able to process some of the things and be able to do predictive maintenance on the edge and not necessarily have to go to the cloud first. They have swappable communication module. Each of these sensors the communication protocol can run from either Bluetooth, LoRa, LTE or cellular or narrowband IoT. And in recent time, just last week, we signed an NDA with a satellite communication provider through MTN that will fall back to satellites in places where cellular connectivity is not available. Now, these provide real-time data monitoring that allows for you to enable things like alert reporting, incident reporting as well. And they are solar powered. And I'm happy to say that we've partnered with one of the biggest and one of the most respected solar power companies in the US called Voltaic, and they supply a lot of the solar panels for a lot of IoT field devices. They are cost effective. We manufacture them locally. As you can see, you saw from the pictures, most of them are locally designed with 3D printing. And as we speak, we are also in the R&D process of actually recycling them and building or developing filament from recycled plastics to build the enclosure for the sensors. So the cycle of keeping it clean, keeping it recyclable, and keeping it green. It also helps us to provide compliance support for industry, so like green reporting. There's also what we call the remote management, calibration, and adjustment, and firmware update. These devices are going to be in the field. So that means that you don't necessarily need to get a human person to go climb on wherever it is and update firmware or check or do everything. This is done remotely through our cloud-based system. Like I mentioned, these are recyclable. When the end of life of one sensor is reached, all you need to do is, we recycle the plastic and build a new enclosure for it. Now, in just a space of 2 years since we started, it's interesting to know that we've chalked a couple of successes. We entered into the Microsoft for Startup program, became a Microsoft partner. As we speak, we are at level 4 of the Microsoft Standard Partners Founders Hub, and we've received $150,000 in cloud spend from Microsoft that we're using to do the processing of all the data that is going in and all the other stuff, which is fully sponsored by Microsoft. And we recently have also been nominated into the prestigious Headshot Prize, which has a prize of £1 million for companies or startups like us trying to solve, sustainability and climate action. And then, like I mentioned, we've done stuff with UNDP as well. Now, we've also been very privileged to have been nominated as part of the finalists for just the just ended Climate Tech Award in Nairobi, Kenya, even though we didn't win, but we're finalists in that. We've also been accepted into the NVIDIA Inception program, which allow us to build a lot of AI models on top of the data we are collecting. And as mentioned, in the Microsoft Founders Hub and also the Headshot Prize. Now, this is not just about Crafted Climate. This is not just about how we've taken this simple question in solving a problem into, a commercial enterprise. But mostly it's about empowering the youth of Africa through this kind of innovation. How do we empower ourselves to solve our own problems? How do we empower ourselves to ask the question of what do we lack and how can we use our own innovations as Africans to solve our own problems? That is what I'm here to share with you. And that is what I want you to take from that determination, curiosity, and persistence. So, key things we want to do is that it is not just a journey for us, it is a reflection of what me, then as a young African, can do if we connect our curiosities and interests together. For the next great startup, it can come from all of you here partaking in this hackathon. The biggest next innovation should come from you or could come from you. For us, people to come with ideas. If you just have an idea, come to that hub and we provide you all the spectrum of services for you to build that idea. So it's about training, it's about providing access. Remember, it started from Arduino, a simple microcontroller. At least today, if you go to other places, you see microcontrollers. Unfortunately, when we started, even in the university level, it was very difficult to get hands on an Arduino microcontroller. So this is part of the journey to say, hey, now we can make this Arduinos or this microcontrollers accessible. We can make sensors accessible through our project and assets and the curiosity of you young minds in building solutions. We as Africans can build the next big innovation to solve our problem. So what is the roadmap for you as an aspiring tech entrepreneur in this space? Well, I'll share a few things with you. First of all, let me simplify that. Learn, right? Learn and use a lot of the free tools. You can talk about Visual Studio Code, Arduino, Platform.io, Fritzing, Node-RED, Wokwi.ai, right? Learn and use these tools. These tools will help you in the long term to build solutions. In this case, when we started, hardware was a problem. Today, you can have tools like Wokwi, and hopefully this time, I'll quickly run to Wokwi and show you how Wokwi works. Wokwi can let you simulate devices on the cloud, and you don't necessarily need to have physical devices. So you are not limited by it. Build, like I mentioned, learn from my story, curiosity. Build, start with small projects. Look around you. What issues can you build solutions for? Because remember, your skills get better not through perfection, but through what? Practice. So build and showcase, document what you've done, put it on GitHub, put it on Hackstack, right? Document it, showcase it, write it so that people can learn from it and improve on it and we can get better. Collaborate like you're doing right now. Join other people building other things and learn from the experience. We did that. We collaborated with people here in the US when we started with Crafted Climate. We learned a lot, we shared a lot. And once you've been able to achieve this, you can now what? Scale. And in scaling, apply for programs, NVIDIA Inception, the Microsoft for Startup Hub. Just yesterday, Google has also launched theirs, Google Accelerator cohort, and I have started. There are a lot of UNICEF also has started some other programs, different accelerator programs that will take your idea, what you built, what you've showcased, what you've collaborated on, and you can scale with it. Now, it is not as smooth as you think, or it's not just a walk in the park. It also comes with challenges. And these are some of the challenges we faced and how you can overcome it, right? Now, funding is one of the biggest challenges that we faced when we started. Until we got some of the support from Microsoft, everything was self-funded. So funding, validation, people will want to validate the product you have. Some people would even have doubts about the product you have, right? but it's all part of the journey. But so is growth, right? I have learned to reframe failure as feedback. If I fail, I see that as feedback. I don't see that as failure that should deter me. Anytime I fail, I see that as feedback. I see that as something I need to go back to drawing board and work on. And so far as you keep going, even when it is lonely, look, sometimes you start with an idea. Some people at some point will think that you're going crazy. And we had the same thing. Some people drop along the line. Today, they're realizing that yes, the dream might be crazy, but the fact that as we are failing, we're taking that failure as feedback and working towards it, we are perfecting it. Today, I'm happy to announce that in the sub region, we're the first among the few startups that is ready to commercialize these local sensors. And we're partnering with EPA of Ghana, EPA of Nigeria, EPA of Liberia in trying to, once we get the commercial quantities out, we're shipping it out to Liberia, shipping out to Nigeria for them. Like I said, you're going to have this, you're going to have issues funding. People are not going to validate your idea. You're going to have doubts, but reframe failure and look at it as an opportunity. So, what is the call to action for you as students in this hackathon and in this way to move as students? Well, product in something. After you build it, share it. Sometimes create a lot of feedback and review around it. Share it, talk about it, and then find your tribe. Fuel you with positivity and fuel you with it. If you're trying to build this, watch out for this step. I did this and it got me, right? And then use it. Apply the technology. Build it and use it. Don't just build it and put it on the shelf. Use it yourself to solve the problem. If me some years ago, I could just walk to Radio Shack to buy a $30, Arduino, and today be nominated for the extra prize for the chance to win £1 million. If I could do this, you can also do the same thing. I want to end here and say that let's make Africa the innovation hub of the world because we have the capacity to do that. We have the minds to do that. We have the brains to do that. And that is what I want to encourage you to do. If you are in doubt, one thing I think you can do is that look out for the SDG goals. As of today, Crafted Climate is, I think, handling about 3 of those goals: sustainable cities, climate action, life on Earth. In all these sustainable goals, there is a solution or there is a problem you can solve with your innovation. So I call you, I entreat you, be curious, don't give up, have that passion, have that dedication, collaborate, and let's innovate the next technologies that the world will use. But most importantly,
Oh,
the next
I need
technologies that
one.
I will use.
See,
With that said, I want to end my presentation here. Thank you for your time. You can reach out to me on any of these platforms. I'm on X, on Facebook, LinkedIn, Instagram is the same handle. You can connect to me on my YouTube channel. You can also connect to me on our WhatsApp channel and join me when I'm going live. And just as I promised, before I open up for the Q&A, right, to share with you, I'm going to quickly show you one of the basic and very interesting tools that you can use, right, if you don't have access to hardware to maybe test some of these things out. So I'm going to quickly do that. Hopefully you can still see my screen. Let me bring up, I'm going to bring up here. I mentioned it as part of the resources. So okay, there we go. So this is it. So this is how Workway looks like. And here, if you want to try an ESP32, you want to try an Arduino, you want to try an STM, a Raspberry Pi, you can do that, right? Just select it. If it's an Arduino, select it. And there are even sample scratch things that you can do, but you can select it if whether you want to use Arduino Uno, the Mega, the Nano, and what it does is that it actually even allows you to create not just the sketch, but as you are adding items to it, right? Let's say I want to add an LED to this. I put this here. Let's say I want to add a resistor or something to it, right? So let's say you add the resistor. I'm just going to connect this and just show to you. And let's see, I'm putting it in 7. And where is the, let's put it here. Let's do 5 volts for this, right? Now, once you do this, check this out. Now, with this, I mean, you can simulate it, or you can also have it, you see it, do the diagram for you, do the libraries, and do the how do you call it? Also run the, how do you call it? The sketch for you. So this is a very useful tool that you can use if you don't have access to a hardware. Like for instance, if you, like I mentioned, I am a hardware geek. So even on my decks right now, I have a C Studio LoRa 1 kit for communication. I have a bunch of groove stuff going on here. But if you don't have access to this hardware, don't let the hardware be the limitation for you. Go ahead, try Wokwi, play around with it, build, test, and learn things from it, and let's innovate the next biggest thing from Africa. Thank you very much, and I'll open up for questions at this point. Thank you.
Thank you very much, Samuel, for the presentation. So the floor is now open for your questions. This has been an inspirational personal journey, and I hope you've learned a lot from it. So please, the questions are open. And in case there's a question in French, Dr. Mamadou Nian, I know you are there, so you can help us.
Okay, George.
And also you can type your questions in the chat window, please.
Yeah, I think there are, okay. In the chat window, I use the language. Okay, good morning, said. Okay, so I see there's a question here. So good morning, sir. Please, to deploy an IoT-based monitoring system at about 15 kilometers from the monitoring site, what communication module is best required? That's a very good question. In the case of Crafted Climate that we did, again, you're going to determine what communication protocol you use based on where you are. If you're in a rural place where cellular connectivity is difficult to come by, your option will be things like LoRa or Sigfox, right? LoRa can travel kilometers, right? If you have the right line of sight or have the right LoRa antennas to use. Example like this kit here is a LoRa 1 kit. So for long distances, what you want to do is that you can build, for example, if you have a lot of sensors in a space, but then you need to communicate with the gateway somewhere, then you can do something like a LoRa mesh, where amongst the devices, they can communicate and collect data and all that, but then use LoRa to send the data kilometers away to a LoRa gateway, and the gateway is connected to internet where connectivity is better. So for example, if you're using a LoRa gateway, the gateway can have like a SIM card and can have a fallback like satellite, can have a fallback like maybe Starlink, right? So for 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 Crafted Climate, we are using a technology from Blues. Now, this can fall back between satellite connectivity and also cellular connectivity. Now, they do something unique. It was one of the challenges we faced when we're doing Crafted Climate. You know that some parts of your country, you have different networks. So there might be a particular area where one particular network might not be stronger. So the kind of connectivity we're using with this particular vendor we're using is a multi-network system. So they are able to adjust to whichever network and give us reliable connectivity. Then, if the cellular connectivity is not good, they're able to defer to satellite or even Wi-Fi if it's available. And I can also share that with you. They are called Blues. So this is the company we're using. And the product we're using for most of our sensors, we have the Note card, right? So there's a Note card cellular, there's a Note card XP, Note card LoRa, and you can have there's a Note card cellular. And so I'll show you how the card looks like, and we've integrated this into our product. So this is how they look like. So we've embedded this into a custom firmware, and this is doing so. We don't use any SIM card. This is a soft SIM or eSIM, so we don't use any SIM card. It's all provisioned by our communication provider. So we can decide to, if we want to change it in a deployment that uses
Samuel, do you
Wi-Fi.
plan to share your screen? Because if you are trying to
Oh,
share your screen, we are not seeing it.
oh, you're not seeing my screen. Oh, apologies, apologies. I thought I was sharing. I thought I was sharing it. Forgive me. Are you seeing it now?
Yes, please.
Okay, sorry. Thanks for that. So this is the partner we're using for our sensors. It's called Blue, and this one here is the LoRa module. So they have different modules. So if you look here, they have the cellular. Let me open this, and then they have the cellular and Wi-Fi. That's why if you realize in our design, we said that our design is modular. So if you are doing a deployment and you want to use only Wi-Fi, all we do is that we just replace this module with a Wi-Fi module. If you want to do a deployment and it's LoRa, we just replace it in LoRa. So to answer your question, if you want to do about 15 kilometers, LoRa or Sigfox is your best bet to do about 15 kilometers of communication for devices. Can you install GPS system on a, is it a drone camera for more data collection? So by default, a lot of the drone communication, you embed GPS on it. So I've seen a lot of the drones that have been developed, whether it is a marine or UAV, whatever that is. Yes, you can always put a GPS module onto it, and that will give you accurate GPS location that you can send. So whether you are using, remember, GPS is not connectivity. GPS is not communication, right? GPS is giving you access to good locations. So you still need, whether you want to use LoRa, you want to use a satellite, or want to use Wi-Fi to transmit that data. Yeah. And so I want to believe that, did you guys see you saw the Wokwi, right? So you can go to wokwi.com and then use this to actually design your circuit and test them out. So you don't need to have an Arduino, physical Arduino, you can use this. I'm just making sure that, how do you call it? I want to make sure that I shared it for you to see it. And I think I shared that for our solar partners, right? We use Voltaic, and I can share. And these are very capable, high quality, high tolerance, high capacity solar panels. So these are the panels that we use. These are the panels we use for our sensors. Yeah, these particular ones. They actually generate enough power for our devices, so our devices can run throughout the night for even 2-3 days, without even the sun. And these are the major. So these are major partners when it comes to our devices, and so they are self-sustaining. We also have what we call the long life batteries, and they are very interesting, especially for LoRa devices. Those batteries can last for 10-20 years on their own because they're high capacitance batteries. So these are the R&D that we are continuing to do, to improve the solutions that you can leverage. Can we integrate plant identification on drone cameras? Yes, you can. You can. You can today with AI cameras that are of lower footprint. You can put cameras on your drone, and that will do processing. Now, let me share this with you, and I'll probably share this as a link. If you these people, right? Seed Studio, right? Seed Studio have an AI camera. Let me see if I can show you this. These are Groove AI cameras. Yeah. Yeah, Vision AI camera. So C Studio has this that allows you can actually deploy your own AI model on the edge. So if you train your model that detects diseases or crop diseases, you can train that model and deploy it on this AI camera and put this camera on top of your drone. And then your drone will be able to detect that without having to send the data to the cloud. Because in most places, the challenge always is, how do I send the data from my field to the cloud if there's no connectivity? But with modules like this, you can train your module to detect the diseases, deploy it on the camera, and then deploy this camera on the drone, and that will work for you. For the Coca-Cola traceability system, the Cocoa traceability system, which one is best required between a QR code, RFID tag, barcodes at both farms? Okay, this is an architectural it's an architectural question, right? And I have seen this implemented in a couple of ways with fallbacks. Now, the first one is actually coordinate, right? So first of all, there is a tag. Now it's a QR code tag, but that's somehow securely embedded or attached to the cocoa, just to make sure that it's not easily moved. But then there is also some if you're talking about the product itself, then you're dealing with, you can use RFID, that is either passive RFID that is activated when it connects to an active tracking point. But else there are I I I want to believe. Let's see if I have one here. Unfortunately, I don't have one here, but I think I've talked about one of them on my YouTube channel. So there are now trackers that support both LoRa and satellite connectivity, and they are quite small form factors, which people can use. They almost function like um the Apple, how do you call it, the AirTags. They almost function the same way. So yeah, you can use that for fallback. Yeah. Any more questions? And also, if the ESP32, I believe S3. Let me find this for you. ESP32 S3. The ESP32 S3, you can actually do AI on board of the S3. So the S3 and the C6, I think, allow you to run, onboard AI. So you can also look into that. Prof, I think there's a question in there for you, but I think, yeah, Prof will do that for you. Yeah, he will provide you the resources on if you want to do drone specific technology. Yes. So embedded systems are generally the same concept. It depends on the sensors, actuators, and what you want to do on it. Whether you want to, like, for instance, you're doing AI, that will determine what microcontroller to use, whether to use a single compute board or to use something like a Raspberry Pi or a microcontroller. That will determine on what you want to put in there, and then that also determine the kind of sensors you want to do. But the embedded system generally is the foundation, so the fundamentals are the same.
Well, I think the questions have been exhausted, and you've answered all of them. That was very, very insightful, and thank you very much, Sami, for engaging the students. This question about whether I can provide the link to learn more about embedded systems on drones, I think where we are now, and as a university students, if you Google this online,
Yeah.
YouTube, there are massive resources, repositories, and
Hmm.
tons
Yeah.
of it coming out every
Yeah.
minute that you can avail yourself of. So preferring one link to another also depends on your level, beginner, intermediate, advanced, and the questions that you want to address with it. So make it the
Yeah.
exercise to really get into some of these things, which is an exciting area. And on that note, I would
Yeah.
like to thank all of you for participating.